Okay, here we go again with quadratic equations, section 2. We're going to be using quadratic equations, and you know by now in this textbook the word using translates to word problems. You know, what good are these concepts if we can't apply them to real world situations? And we do have a lot of real-world situations that can be explained by the quadratic function. Before we go forward with this, let's just remember, with a word problem, what are the basic steps? First of all, understand the problem. Now, this could be tricky. You've got to read carefully. What I advise that you do is write down what you think are critical bits of information as you read through the problem. Also, what you want to do is, whatever they're asking you to find, it's usually a good practice to make that the variable. Then you have a plan and you carry it out. You have an answer, but that's not the end. You want to check. And one of the things you want to do is ask yourself this question: does it make sense? Dims. Does it make sense? It's easy to misunderstand slightly what the problem is asking you to do, or develop a plan that isn't quite on target. Get an answer, deliver that answer, and find out later it was not a sensible answer because I forgot to consider, did this answer make sense? So a simple thing to do at the end to save yourself embarrassment. We're going to do a little review of what we had done previously. Here I've got a quadratic expression. I like the fact that these are already set to 0. So if I want to use the 0 product property, I'm already set up for that. We remember what that is. We first set one side to 0, and then we take the sum that we've got here and convert it into a product. Okay, in this case, I think a sensible way to go about this would be, first of all, to divide everything by 3. I could see that we've got a common factor here. When I divide 3 by 3, I get 1, so then I'll have x squared. I divide 6 by 3, and I have a plus 2. And I divide 0 by 3, and I have still 0. So that works nicely, doesn't it? Now, my problem is that I need a product, and I don't have a product here. Let me get a product. Let's see. If I take x out of both of these, I'll have x plus 2. Now, this is not usually an option for us. In this case, there was no number. Look down below at 2. There's a number here. There's no way I could factor x out because there's no x in this term. It was possible here because each term on this side had an x in it. Now I can say x equals 2 and x plus 2. What am I saying? Sorry about that. It's not x equals 2. I can hear you. You're saying, Mrs. Turner, for heaven's sakes. X equals 0. Afraid I was looking ahead. X plus 2 equals 0. And of course, this is not going to end up being x equals 2. It's going to end up being x equals negative 2 when I subtract it. I subtract a 2 from both sides. So there are my two answers. I know because I've got a quadratic with a power of 2, I'm going to have two answers. This next one is a little trickier. because I don't think I'm going to be able to factor that. And therefore, I'm going to go right into this technique that we practiced in our last session, completing the square. That's going to be very valuable to us coming up when we study conics, completing the square. We'll be doing a lot of it. So we've got x squared plus 10x, and I'm going to want to have a perfect square trinomial right here equal to something. So this plus 23 is just in my way right now, so I'm going to subtract this from both sides. Now, what do? Well, I look at my leading coefficient, which is fortunately 1. It makes things so much easier for me. Then I take the coefficient on my linear term, which is 10, positive 10. I divide it by 2, divide by 2, and square. Well, when I divide it by 2, it became 5. So I'm going to have 25 is what I need to add here. I add 25, and I immediately put my equation out of balance. It's no longer true. I better remember, and it's so easy to forget, better remember to add 25 to the other side at the same time. Now, I do have a perfect square trinomial, and it will always factor into a binomial squared. I take the square root of x squared, which is x. I take the square root of 25, which is 5, and I take the sign from the middle. And that's going to be equal to, let's see, when I add these two together, I have a plus 2. Now I can take the square root of this side, and what I do to one side, I have to do to the other, remembering that this has to be plus or minus. The square root and the power of 2 undo each other, leaving me with just what was inside the parentheses. And the next thing we do is we subtract 5 from both sides, and we have our two solutions for x. Minus 5 plus the square root of 2, or minus 5 minus the square root of 2. So I can express both solutions in this case just using plus or minus. Okay, so we're clear about how to do those techniques, and we're going to go on and look at problem solving. One of the things that's important here is to name whatever are the unknown quantities and to specify the units of measurement. So let's take a look at this. If the sides of a field are given in miles, so let me draw a field. And they don't tell us what the shape is. I'm just going to assume it's rectangular. If the sides are given in miles, so I've got some length here in miles, what will the unit of measurement be for the area of this field? Well, you could probably figure it out if you think about if it is rectangular, it would be length times width. You remember this from geometry, which would be miles times miles. So the unit of measurement will be square miles. Or another way we might write it is if the legs of a right triangle are the lengths 5 and 12, what is the length of the hypotenuse? Again, we're calling on your memory of geometry. So if I have, pretend that's a nice looking, which it isn't, but pretend it's a nice looking triangle. This side is 12, this side is 5, and I want to know what is the length of the hypotenuse. Thank goodness for Pythagoras. He gave us just what we needed to solve this, which was that the square of the hypotenuse is equal to the square of one leg plus the square of the other leg, which we would find is 25 plus 144. So the hypotenuse squared is equal to 169. Now, before we go forward and figure out what the hypotenuse is, I want to point out to you that in this problem, I'm going to move up here a bit, I named the unknown quantity. I named it, this is the unknown quantity, right? I named it h. It would have been a good idea if I had done this. H equals the length of the hypotenuse. It's always a good idea to define your variable that way. Now I'm going to take the square root of this and plus or minus the square root of this, and I'll have that the hypotenuse is equal to plus or minus 13. Now, a negative doesn't make any sense at all. So, you know that question, does it make sense? You're not going to tell me that the hypotenuse is equal to negative 13 because we'll say, that doesn't make sense. The hypotenuse is equal to 13. We do not know what the units are. They weren't given to us. So we just do that. Okay, here's a word problem. Finally, we get into it. Thomas has mowed a large rectangular plot of grass. All right. So as I'm reading this, I think I should draw myself a rectangle. Pretend that's a rectangle. He estimates the area to be 400 square feet. He must be quite good with measurement, huh? I have no idea how I would do that. 400 square feet. So we know what units of measure we're working in. We're working in feet. Elva walks around the plot and she estimates the perimeter to be 100 feet. Find the approximate dimensions of the plot. So what we're looking for are the dimensions. It's rectangular, so I'm going to say L equals the length and W equals the width. So length and width. Now I could have put them the opposite way. I could say this is the width and this is the length. Doesn't matter, as long as they are at right angles to each other. Okay, now from geometry, what do you remember about area? If we had to express it in terms of length and width, how would you express it? We did it just a moment ago, didn't we? It's length times width. Perimeter. If we had to express that in terms of length and width, what would that be? Two lengths, this one and this one, plus two widths. Now, we know what the area is estimated to be, and remember, because we're working with estimates, we're only going for an approximate. This would be sort of a guesstimate. We do, in life, we do that sort of estimating all the time. So I can say that length times width is equal to 400. That's a terrible looking equal sign. Okay, equal to 400. And 2L plus 2W is equal to 100. I have a system of equations here. Two variables with two equations. Can I solve it? Yes. If I have two unknowns, I need two equations. I have them. Well, what are the two ways we have to solve systems of equations? Well, three if you're thinking of graphing, but let's forget graphing. We'll just think algebraically. We've got substitution, and linear combination. In linear combination, we line the variables up, all the L's and all the W's and the constants. That's not going to work here because this is being multiplied. However, I think we could do substitution. All we need to do is solve this for either L or W. Well, suppose I decide to solve for L. So I'm going to say L is equal to 400 divided by W. See what I did? I divided this side by W and this side by W. Now I can take this and substitute it in here every place I have L. So instead of writing 2L, I'm going to say 2 times 400 divided by W plus 2W equals 100. I'm wanting to solve for W. I'm going to extend this page. I'm wanting to solve for W, so I'm going to have to figure out some way of getting W by itself. And I do not like having W down here. Oh, something I just noticed. See this? 2, 2, and an even number? I could divide this whole thing by 2 right now, which would give me, write it over here, 400 over W plus W equals 50. Okay. It's still a problem, though, because I don't like this W in my denominator. Do you remember what we did in cases like this? We called it clearing the fractions. How did we clear fractions? We found a common denominator, and then we multiplied the whole equation by that. So this W is going to be multiplied times each term and on both sides. When I multiply this first one by W, I'm going to get 400. When I multiply this next one by W, I'm going to get W squared. And when I multiply this one by W, I get 50 W. I am hoping that at this point you are already thinking of the zero product property. Anytime you see a quadratic, I'd like it if you would just automatically start thinking of the zero product property. Well, I don't have a zero, but I can get it easy enough, right? I can take this equation and subtract 50W from both sides. The other thing I'm going to want to do is I'm going to want to line these up in descending power order, sort of standard form. So I'm going to swap these around. It's going to be W squared. I'm going to subtract 50W from both sides. Let me put that in here. Plus 400 equals 0. So I've got the 0. I don't have the product. Yikes. All right, let's think about it. Are there two factors of 400 that when I add them up will equal 50. Let's think about factors of 400. Oh my goodness, it's got to be a negative. Both of these will be negative. Okay. Okay, so it could be, what could we use here? 25 and, how many times would 25 go in? 25 and 16. That doesn't do it. That adds up to, let's see, 41. We need it to add up to 50. All right, what else would work? Well, let's just keep trying some. How about if we did negative 20 and negative 20? That would multiply together to be 400. But now that's only 40. Boy, we were closer back here. So what else could we try? What about, oh, I don't know. I went with a negative 50 and a negative 8. That would, still wouldn't be right. Now I've gone too large. Anybody out there figure this out? My goodness, what is it? I'm thinking, you've probably got your calculator going. I haven't. Let's see, what does go into this evenly? Does 15 go in evenly? Darned if I know. Okay, 15 into 400. Yeah, you've already got this figured out because you've got your calculator out. And I should have my calculator out. I know, I know. Nope, that's not it. Okay. Tell me. I don't want to spend any more time on this. Tell me tomorrow what you found for factors there. I'll check your notes. You can show me how that factored. Once you know how it factors, we're going to have W minus something times W minus something else equals 0. And when we solve each of these, we will have our dimensions. We'll go on to another problem. Yeah, I know. I should have kept with it. A ladder is 2 feet longer than the height of a certain wall. Okay, so let's give ourselves a wall. We're going to assume that the wall is perpendicular to the ground. Ladder is 2 feet longer than the height of the wall. All right. When the top of the ladder is placed against the top of the wall, all right, the distance from the base of the ladder, right here, to the wall is exactly equal to the height of the wall. Oh, for heaven's sakes. Well, my drawing is wrong. The distance from the base of the ladder to the wall is exactly equal to the height of the wall. So it actually looks like that, an isosceles triangle. How high is the wall? So the thing we're interested in here is right here. How high is this wall? Pythagorean to the rescue. The Pythagorean theorem. Let's see. Oh, but we don't know a whole lot, do we? We've got, I'm going to have to use y, I guess. The height of the ladder is y. And It's 2 feet longer. Y plus 2 equals X. True? All right. And the Pythagorean theorem tells me, oh, and we were told that these are equal, right? So I can say x squared plus x squared equals y plus equals, equals y squared. So I've got two equations, and I've got two variables. Because I don't know the height of the ladder, that's y. I probably should define that, right? Write it over here. Ladder length, and x equals wall height. Two variables, two equations. That's good. I can work with this. This equation here could be rewritten as 2x squared equals y squared. So maybe I could rewrite this one too, because I want to solve for x. I could say, if I subtract 2 from both sides, I could say y equals x minus 2. Okay, I'm going to write those two equations down here. Y equals x. How awful is my handwriting? Whoops. Y equals x minus 2 and 2x squared equals y squared. So here's my system of equations that I'm going to use, and I want to solve for, since the question is how high is the wall, I want to solve for x. So I'm going to substitute in, instead of using y here, I'm going to use x minus 2. So I'll have 2x squared equals, remember, instead of y, I'm going to use x minus 2. I've got quadratic, so yes, zero product property, of course. Wow. Well, I better be thinking about getting my 0 over here. So I'll subtract x squared from both sides, and my 2x squared becomes 1x squared. I'm going to add 4x to both sides, and I'm going to subtract 4 from both sides. Now let's see, can we factor this? Can we factor this? You know, I'm not even going to try to factor it. I'm going to complete the square. Of course, that's what we were learning. I should be practicing it here. Maybe if I go back to the previous problem and try completing the square, I'll get somewhere with it. Okay, so I added 4 to both sides. And how do I complete the square on this? I take half of this, which is 2, and square it. Plus 4. What I do to one side, I must do to the other, or else it goes out of balance. This will be a binomial squared, x plus 2 equals 8. Let me extend this page. This is exciting now. I can see how we can get to an answer. We're going to take the square root of this and the square root of this, and of course plus or minus. And that will give us x plus 2 equals plus or minus. Now, let's think about the square root of 8 for a moment before I write it down. That's the same. It's got a perfect square in it, right? All that work that we did with radicals, see how it's going to pay off for us now? That's the same as 2 square roots of 2. So instead of writing the square root of 8, I'm going to simplify that to 2 square roots of 2. Now I'm going to subtract 2 from both sides, and I'll have x equals a negative 2 plus or minus 2 square roots of 2. The next question, does it make sense? We know a negative dimension would not make sense. And if I say negative 2 and I subtract 2 square roots of 2, definitely we'll have a negative number. So x has to be negative 2 plus 2 square roots of 2. And do we have a unit of measure here? Yes, we're talking about feet. Now it is a pretty crummy looking answer, isn't it? I mean, if you're ever talking to anybody, and you, like a carpenter or something, and you told them negative 2 plus 2 square roots of 2 feet, they would laugh at you. So you might want to figure out what this is in decimal, but this is the exact answer. We're going to call it quits for the day. If you want to go back and try completing the square on that previous problem, we might find, there it is, whoops, we might find we could get the answer by completing the square. I didn't think we would need that, but you tell me at our next class. For those of you who are curious and want to hang on for a few more minutes, I'm going to go back to that problem that had me puzzled. It takes about 5 minutes. Okay, officially we've stopped. I just couldn't bear not trying to do completing the square on this. If it does factor successfully, it'll show up when we try to complete the square. So let's go to the formula we were working with right here. I'm going to write it up here. W squared minus 50W plus, well, forget the plus, W squared minus 50W. Because when I complete the square, what am I going to do with that constant? I'm actually going to move it to the other side. So I'll save myself a step. I'll subtract 400 from both sides, minus 400. Now, what do I need to put in here? Half of 50, which is 25. 25 squared is plus 625. And what I do to one side, I have to do to the other side. So I end up with a binomial W, take the square root of 625 and the sign from the middle term, binomial squared, is equal to 225, right? 625 minus 400. I take the square root of both. This will be plus or minus. And I get W minus 25 equals plus or minus. Now, is there a perfect square in there? Yes, there certainly is. The square root of 25 times, what would that be? 25, the square root of 9. Oh, this is so interesting. Okay, so I've got W minus 25 is equal to plus or minus 5 times 3. So 15 did go in evenly? Oh! It did! I made a mistake back here. No, I didn't. Gives me 10. $15 doesn't go into 100 evenly. So W equals 25 plus or minus 15. So W is equal to either 40 or W is equal to 10. Oh, that's what it was. I bet you saw it, and I couldn't hear you. 40 and 10. That is so obvious. I couldn't get there, so I had to complete the square. Okay, so there you are. Another 5 minutes to solve this problem. Thank you for your patience.